Okay, now we get to talk about testing, everybody's favorite subject. Well, testing is one of my favorite subjects because I love it when code is well tested that I write, because when it is, it works. So let's think about some things here. Testing research software, let's dive in. Two true statements. The first one, research software will likely have a much shorter lifespan than commercial software. This is true. A lot of the software you write for your research projects will probably be thrown away after the project is done. It may be the case that some of it survives. If you write your code well, you might write tools that you could pull along to another project. But a lot of it is going to be so customized to the particulars of that research project that it'll be left behind. And that's just to be expected. So I consider that a true statement. Here's another true statement. It's just as important that research software works correctly as it is that commercial software works correctly. Now, with commercial software, there are different incentives and costs for when there are quality issues, obviously, than research. But in research, if you have software supporting information in a paper and it's not working as you expect, the conclusions of the paper could be incorrect. They might not be replicable. So it's pretty obvious to me that both of these are true. The problem is that somehow creeping into this is this mindset. It's just a prototype. We don't want to spend the time to test it rigorously because we're going to throw it away. It's just a prototype. I have a philosophical problem with this, because if what you're trying to assess in the prototype is if something looks promising, if you have bugs in that, you're not going to be able to answer that question well. So, especially if an advisor does not have a firm grounding in software engineering, if they're more in the theoretical space, they may not just get that you have to spend a certain amount of time testing software so that you can know that it works. So I'm just going to try to plant in your mind this concept of a research prototype versus a research production code. So the research prototype, yeah, maybe you can try something out and assess it, but if you're going to have data winding up in a paper, you really want to have research production code. You want to have the confidence to tell your advisor, if we want it to work, we're going to need to have some tests around this code to make sure that the critical pieces, at least, are doing what we think they are supposed to do. Okay, I'm going to tell you a quick story. I once, many years ago, worked with a student that built a predictor. Now, this was a machine learning algorithm, and so these algorithms don't have logic, they work in a different way, so you can't test logic with these algorithms. But he was super sure that his logic around the predictor and the way he had trained everything was good, that he was done, that it was working right. And I was skeptical, and so we began a little relationship here. I have the pseudocode for I in range 3. That person said, I'm sure it works. I said, here's some special data I generated to excite an edge case. Them, I can't believe I missed that bug. And we iterated through that 3 different times. So it was a great learning opportunity for that student, a great lesson in humility, that it's just very hard in these complex systems to find all the bugs, to know they're there without doing the testing. Okay, so how do we know there are no bugs that could affect results? Is it that we're looking at the output of the runs that we did, and if they kind of match what we expect, can we say that the code is working? Or is it the case that the software needs to be designed as a set of independently testable components that have in fact been independently tested? Here's my answer. Okay, I'm beating this one to death here, so let me move on. Let me talk about test-driven development. Many of you have heard of this, and some of you may not have. So in my philosophy in these videos is that if I've ever encountered students that don't know about things, because every student comes through a different pathway in life, I'm going to mention it in these videos. So a couple minutes on test-driven development, and we'll orient the people that are new to it. So basically, a unit test is written to test a little piece of software, and you write the test before you write the component. You think through the test, you write the test logic, thinking about the use cases you're trying to cover, and get them all in the proper format. And then you start writing the code, and you keep writing the code until all the tests pass. Then you know you're done. At that point, your code is ready to be dropped into your application with some confidence that it's working. The tests provide a record of what you had considered at implementation time, so it's easier to spot and add tests for forgotten use cases. That's awesome. And I'm just going to back up here, because some of these projects are multi-year projects, and there might be students coming and going. You might find yourself coming in the third year of a 5-year project, inheriting a code base, needing to change it, and you would love to have unit tests to look at to understand what they considered at implementation time. Okay, here's the big one. Code written using test-driven development is less spaghettified, more maintainable, with better decoupling and fewer interdependencies. The code just winds up being way better because the act of unit testing it pushes you into these better behaviors. You don't even have to think about it. It's like you're starting to write a test. Okay, how am I going to test it? And you're like, wait, I don't want to have to make a new object of some other class and pass it into this test so that I can test this class. That's too much coupling. I don't want that. I want to have my test be simpler. And so all the components wind up being just on their own more and not depending on each other, which is fantastic. But the huge thing is that you always are moving forward. You know that as you're adding tests, you're adding logic, that as long as all your tests keep passing, you're not breaking anything. It is so easy to break code that's not unit tested when you add things, especially if the skill level, the experience level of the student who wrote it was not top notch. This is just, life is better when you don't have to go back and fix things, or a bug happens and you have no idea where to look. No idea where to look. If you write code and you break a test, you know exactly where to look, right? It's just, I love unit testing. It just makes me happy. There's another tool called coverage.py that helps you assess how much of your code has been executed, including the tests. So that's something you'd want to look into as well. Okay, but as with everything in life, there are downsides. Downsides of test-driven development. If you get down the road and you've written a whole bunch of tests and you realize the design needs to fundamentally change, then many or even all of what you've written test-wise needs to be thrown out because it's now potentially irrelevant. That's painful. So at least some will need to be written. So unit tests are really a second application that you're maintaining. So you have two sets of software that you have to maintain. Okay, so I advocate a balance. So be intelligent about thinking about what you're going to test, because you're likely not going to have enough time to write and maintain tests for every little piece of code you write. So test components that have logic that will likely need to be augmented or changed. Now you may not know this when you're writing a component, but you may, because it might be kind of like in the center of what's being studied, and you know that's the thing you're going to be making changes to. So yeah, if you know stuff is going to change or be augmented, you want to wrap it in tests. If components have complex logic, that's what you want to test. There's less risk in skipping components that do very simple things with minimal logic. Like if there's a function that has one if statement in it, and the function is 4 lines long or 10 lines long, or a small function, and you can just read it, and the if statement there is just utterly comprehensible, and the code is well written, you might get away with not writing a test, and it will be fine. And also, some kinds of things, they really only have one use case in essence, and you can kind of tell that they work just by if they work at all. So there are cases like that. One thing that can help is if you resist the temptation to put too much responsibility into one class. The busier and the bigger a class is, the more logic it has, the more complex it gets, and so testing gets more complicated. So if you're writing unit tests first, that will actually it will help push you into resisting the temptation to put too much responsibility into things, because it will lead you into less coupled code, which usually means more smaller parts to do things. Okay, to simplify unit testing, make components friendly to simple data. So, for example, I wrote a component to do stuff on a grid, and the component would work on any n by m grid, which could be arbitrarily large. But all the edge cases could be surfaced using tiny grids as inputs. So grids that were 1 by 3 or 1 by 4, 2 by 3, I didn't have to make a 50 by 100 grid in my code to test stuff. So you can kind of be intelligent about that. And with this simpler data, it's easier to read and comprehend the tests, and easier to spot use cases that weren't covered. What about testing machine learning algorithms? Well, they're a completely different animal because they're not based on logic. They're not rules that you've written down. They're a different animal. So I recommend that you Google testing learning algorithms. I did it. Some stuff came up. It looked like there were some good resources there. Okay, what about this AI thing that's like all the rage now? I'm guessing it's going to be the rage for quite a while. A fad. So GitHub Copilot, I used it for the second half of the project I most recently worked on. And it was very interesting. It was very impressive. One thing I didn't get to try was something that turned up when I was looking around preparing this video. There's a YouTube video on Free Code Camp that shows how to test Python code, how to write tests using ChatGPT to help you. And so that looked pretty interesting. I didn't have time to try it out, but you might want to check into that because it might greatly simplify, it might revolutionarily simplify writing unit tests. So definitely look into that. GitHub Copilot served me very well, especially in doing repetitive things. It just got, I could do stuff 4 times as fast, certain things, just filling out big tables that were, had a lot of self-similar lines, and it would figure out what, would guess what I wanted to do next, and it was correct very, very often. Sometimes not, but just very often. The one time it generated syntax for me in some code that I didn't understand, and I was like, it probably knows what it's doing. There was a bug in it. It didn't work right, and that cost me tangible time. So that was kind of like a foreshadowing of what I saw the other day when I was looking around getting my grounding for this video. There was a recent article that reported that there is a significant drop in code quality when Copilot was used. So this doesn't really surprise me that if you're relying on a tool that you don't really understand and it's going to hallucinate sometimes, and you don't check things well enough, that there's going to be a cost. So maybe that'll improve, but that's just at this point in time, which is the beginning of 2024, that's the state of things. Okay, I think that's all I'm going to really spend time talking about. I'm a huge fan of unit tests. I think they really help make the code better. You know it works. You always move forward, but they have a cost, so you have to be intelligent about where you focus most of your effort because you won't have time to do everything. I didn't talk about system tests, like end-to-end tests. That's something that probably will just roll out organically for you when you're wanting to make sure your whole show is working. But certainly don't forget about those either. I will say one more thing. So I'm not the sharpest tool in the shed, as they say. I'm not the most brilliant software developer that ever was. What I have going for me is lots of experience, lots of people skills. I've seen a lot of things, etc., etc. I've worked in a lot of different contexts, so I tend to be a generalist. I know how to do a lot of things pretty good, and I can spin up in things quickly. I don't have humongous deep expertise into any one area. But it might be true that there might be developers out there that are so good that their code will just work the first time. I've never met this person. But I know I write buggy code because with my capacities and my particular attention and just everything about me, I know that there's going to be bugs in my code. However, I'm good at writing unit tests, so I know I can write good code that works because I cover my own behind, as they say. So whatever your skill level, as long as you write your unit tests in a simple way where you're not introducing bugs in the tests, which is possible, if you write clean tests, you're going to elevate your skills way up. You're going to write amazing software that really works and does what it advertises. And that's going to be a great feeling. So there's my final public service announcement about unit testing. All right, we'll see you next time.